Hello. Can anyone hear me? So, welcome all to the talk about microservices in Kotlin. I'm Haim, and I want to share with you our experiences with this wonderful language in the last 1.5 years. This is not going to be an introduction to Kotlin, rather the manners that we use this language in production. And it will not going to be a comparison between Kotlin and Scala, although it is very tempting to do so. So, a little bit about me. I'm developing software since the age of 12. My first computer was Commodore 64. Anyone familiar with Commodore 64? Okay, so you're old enough. And I've been developing, my main programming language was, the first one was BASIC, then I moved to Pascal, and then C and C++, and now Kotlin. I've been experiencing with a lot of other languages, but these are my primary languages, which I do most of my job in every time in my life. During my career, I've been a developer, an architect, a group manager, and I even had an 8-year episode of an independent consultant focusing on performance, garbage collection, and JVM optimizations. Right now, I am the head of backend engineering in Next Insurance, and I also one of the manager of Java IL, which is the Israeli Java user group. I have 2 wonderful daughters, and I'm married, and also a dog named Mushu, after the character in the movie Mulan. And yes, he's also trained to respond to the keyword Dracarys. You don't want to know what's the effect of that. A little bit about Next Insurance. It was founded at the beginning of 2016, and it aimed to disrupt the insurance field. It's an insurtech company. It's a very hot field in the startup arena now. It's providing an online experience that is simple, fast, and transparent. Our headquarters is in Palo Alto, and the R&D is in Israel. And we started developing our application in 2016 on May, and when I was starting, I was the first backend developer. And since I'm very proficient with Java and appreciate the ecosystem and the platform, I knew that I want to write code in this area. So I started developing in Java, and a few weeks later, I was thinking about alternatives. I was looking for something else. And what are the possibilities in the JVM arena? We have, of course, Java, and of course, the flavor of Java 8, which has all the functional programming constructs. We have the loosely typed languages like Groovy and JRuby, which are not my type, because I like strong typing. And we have Ceylon, which is not widely adopted, and it looked like a very big risk, although it's a very nice language. And there was Scala. And my experience with Scala, although it's quite an amazing language, was not very good in my previous work. It has some problems. The first one is backward compatibility, like you need to have versions for every release of Scala. The second was a little bit complexity that was introduced into the language. I think this has gone too far for most of the developers. And another thing is that compilation was very long and very painful. And of course, there's the king beyond the wall, the brackets wall, the closure. I can't read this language, and I don't bother. So Kotlin falls something around here. It has less powerful idioms than Scala, which can be also a benefit because it's easier to learn. So what is Kotlin? Anyone has any experience with Kotlin? Cool. Has anyone did Kotlin development? Anyone in production? OK. So Kotlin is a strongly typed programming language. It is targeted for the JVM, Android, and JavaScript. It is 100% interoperable with the Java and the Java ecosystem. And it was developed by JetBrains. So if you adore IntelliJ, as I do, I think that you might like Kotlin. It was revealed in 2011, which is not very long ago, but it also means that it's not really new. And the first general availability version was released on February 2016, 3 months before we started developing code. The current version is 1.151, and version 1.2 is in RC stage and probably released in a few days or weeks. The design goals of Kotlin was to be concise, safe, versatile, practical, and interoperable. Okay? So from our point of view, when we wanted to develop our backend, I think that the fact that it was practical and interoperable with the Java ecosystem was the main benefits that we wanted to get from this language. And when you make like technical decisions that are quite bleeding edge and you choose technologies, the most frightening effect that you really want to be, not to be in that position, is that a few years later you will look at your decision and you say, what the hell did I do? That was a big mistake. And there is even worse scenarios when your managers tell you, what the hell did you do? Why did you choose this technology, right? It probably happened to all of you. You start with something, it looks really great, and a few months later, everything collapses. And I'm here to tell you that it's not the case with Kotlin. The technical decision, I think, is a huge success from our perspective, and I'll try to explain you why.29 of all, it's in production. We have 9 backend developers now developing 29 Maven modules, and we reached the position of about 100,000 lines of code in Kotlin. And we keep like 5K lines of Java code just to make sure that everything continues to play nicely with each other. We have 8 microservices and 12 Lambda functions that are in production, and all of them are written in Kotlin. And even the front-end guys use Kotlin for their integration test with Selenium. And when it is in production, we didn't experience any instability, no memory leaks, no crashes, no bad behaviors as a result of Kotlin environment. Only from our bugs, okay? Only the bugs that we make, we need to fix them. During this 1.5 years, we upgraded from 1.02 to 1.151, where 1.1 was a major release. It was the first version that supported Java 8 bytecode, and it was quite a major release, and none of the version upgrades caused any breaking changes or had any problems that was not just changing the version in the build files. So migration from one version to another is smooth until now. I don't know what will happen when we need to move to JDK 9, but probably it will not be easy as it will for all of us, right? And another issue is Kotlin adoption. It seems like Kotlin is getting a lot of interest in the community. In the last Java 1, there was about 9 talks about Kotlin, and a year before it was only 1, I think. It's declared as an official language for Android by Google and endorsed by Google. And the community has a lot of enthusiasm about this language. Okay, a lot of Android developers has adopted this language, but also in the backend. One more issue I want to raise is the onboarding. I was the only developer, now we have 9. The onboarding process is extremely easy. If you take a Java developer and he gets into the company, it takes him about the same time he needs to understand what the hell is going on with your architecture, with your products, etc. So it's not putting another burden on onboarding new developers, okay? And the developers are quite happy with moving to Kotlin because it looks something new. It doesn't look very complicated and frightening. And it seems to them like it is a right direction or something that they should do. So even recruiting is quite easy because we have a huge number of Java developers. We can just switch them to Kotlin. Regarding the ecosystem, Kotlin almost doesn't have an ecosystem because it is relying on the Java huge ecosystem that already exists. Every open source project or library that we wanted to test was working perfectly with Kotlin. Just add the dependency and it runs, okay? And this is due to 2 design decisions that was taken by the developers of the language. The first one is that every primitive in Kotlin and every class in Kotlin which represent primitive is actually a Java primitive behind the scenes, okay? And the other thing, the second thing, which is even more important, all the collections in Kotlin are just wrapper or syntactic sugar for Java collections, okay? So the Kotlin developers of the language did not introduce new collections, which they probably could have written better than what was written like 20 years ago. But as a result, integration with all third party is working seamlessly. A little bit on collections in Kotlin. When you want to create a new map, you just use the map of method. It is similar to what we have now in Java 9, but it did not exist in the system in Java before that. So when you create a map in Kotlin, it is immutable. You cannot assign to it, okay? By the way, using the brackets operator or the index operator is the way to get from a map and to put to a map. In order to make a map mutable, you will need to create a mutable map of. Behind the scenes, there are no immutable objects in collection in Kotlin. It is just a wrapper and a view on mutable collections, which is not perfect, but it also improves the interoperability with Java. Creating lists is just using a list of, and on Kotlin 1.2, you will be able to use brackets operator in order to create lists. We're using roughly this ecosystem for both developing microservices and Lambda serverless functions. We're using Drop Wizard as our microservices framework. By the way, regarding Drop Wizard, I'm not sure it was a very bright technical decision at the point. We probably will replace it soon. So it works perfectly with all of these except for Mockito, okay, which is generator of mock objects in testing frameworks. And in order to solve the problems that we have with Mockito, there is a library named Mockito Kotlin, which solves several problems. And what are the problems with Mockito? First of all, when, which is used widely in Mockito, is a reserved word in Kotlin. So you cannot use when with Mockito. You can put backticks to solve this issue, but Mockito Kotlin adds a method whenever instead. Another thing is that when you use a mock object, sometimes the framework of Mockito just returns null. And this causes problems with all the null safety mechanisms that exist in Kotlin that we will discuss a bit later. And in addition, there is some kind of a nice DSL-like flavor of interacting with Mockito. So if you're using Kotlin and you want to mock objects, use Mockito Kotlin. Regarding project organization, we don't have a separate build files or separate libraries or separate source paths for Kotlin. We just put it in the Java source path. Okay? So Java code and Kotlin code reside side by side in our projects. Mostly Kotlin because we don't develop any new code in Java. And in order to use it in runtime, you will need to add a library called Kotlin stdlib. If you want to add reflections, then use Kotlin reflect. And if you're compiling or targeting JDK 7 or JDK 9 bytecode, you have some additional syntactic sugar and a nice function existing in Kotlin stdlib JRE7 and Kotlin stdlib JRE8. So what I want to do now is to cover some of the language features that exist in Kotlin and show you how we are using them for our purposes. So the first one that I want to discuss is extension functions. What are extension functions? Extension functions are a mechanism to add method on interfaces and classes without inheriting from them, with no inheritance. How can this be done? Simply by adding some kind of a syntactic sugar of static method that take the receiver of the object as the first parameter. So for example, we can define a function called paperWrap, which takes a string and returns a string by adding like brackets around the string. Okay, so now we have defined an extension function on string, which we later use as if it was part of the original implementation, although it is not. It is not like monkey patching in Ruby, like you really change things. It is just something that is added on top, and it looks like it is part of the object. So what are we doing with this? The first issue that we used to solve is the annoying problem of the result set. Has anyone encountered the fact that when you take from a result set a primitive, and if it is nullable in the database, what will you get? 0, right? You take long from a result set, you get 0. And if you want to make sure that it is null or 0, you need to call to another method that is called wasNull. This is really annoying. We're using extension function to add another function to ResultSet interface, which is called getNullableLong. And in that case, whenever you call it, you get back a long question marks, which means that it can also be null, and it will return null instead of a 0 when it is null in the database. Another thing that we are doing with extension function is logging duration of endpoints. since we don't have a lot of scale at the moment, we are able to report duration for all our endpoints to our logging system. We are using logs.io, which is a service which provides Elasticsearch log/Kibana stack, and all we need to do is to report our logs there, and we can see Kibana reports and all this stuff. And we want to report duration for endpoints. And how are we doing it? Basically, we want to add to the MDC another field that is called duration. And we created a method that is called info-with-duration, which takes the same API as SLF4J logger and invoke it, but it invoke it inside of a Lambda expression, which is called loggerAction with duration. We pass a function to loggerAction with duration, which wraps it with additional data. And how it is implemented. First of all, we have a request filter, which whenever we get a new request to our server, we store on the MDC the start time of the current transaction that we want to handle. And we add another filter for the response that whenever the call has ended, we just record it by using the info with duration. Okay? So how do we implement the loggerAction with duration? It is a function, an extension function, that takes an action, which is a Lambda expression, and updates the duration MDC value. We will show in a minute what does it mean. Invoke the action, and then remove the duration key from the MDC. Okay? So it initializes something and then removes it. And then we have the duration. And what is update duration with MDC value? It takes the transaction start time and subtracts it from the current time. So in the end, you have another field in the MDC which we can export in logs.io that has the duration for the transaction. And we can also call it from code everywhere in our program and get the duration from the beginning to the point that we want to use. And it is not running when we don't want it to. We don't want any log. We don't want all the logging actions to use this mechanism. So it doesn't put a lot of overhead on our system. The second thing that I want to show you is how we utilize and tackle null safety. So Kotlin has a very nice language feature that I think that only exists in Swift, which is the language to develop iOS new applications. That in Kotlin, what you have, every type can be nullable or not nullable. So for example, string is not a nullable type. Okay, if you try to put null into a string, you will get Kotlin null pointer exception. If you want to be able to write to a string nullable value, you will need to declare it as string question mark. It is very similar in concept to option of t in Scala or optional of t in Java, but it is much nicer and cleaner syntax. Okay. So beside defining the nullable data types, what else can you do on these creatures? First of all, whenever you have a nullable data type, you can invoke the safe call operator, which is question mark dot. It means that if the object is null, you will not get a null pointer exception, rather the operator will return null. So in that case, if we take a string x and try to calculate the length of it, if it is null, we will get null. If it is not null, we will get its length. And there is also the Elvis operator, which takes something that is nullable, and if it is null, puts a default value. So the result of that is that if the string was null, we will get an empty string, and if it is, actually this will not compile because I changed it like 5 minutes before the talk, but you get the point. And the last thing that I want to cover about it is the double bang operator. If you have a nullable object and you apply to it the double bang operator, then if it is null, you will get an exception, and if it is not null, you will get an object that is from type that is not nullable. It's like eliminating nulls. So this sounds like a great idea, right? I guess that everyone that didn't work with such mechanism is really enthusiastic at this point. But as a matter of fact, it is not that easy, because it is very easy to pollute your code with nulls. And that happens from 2 reasons. First of all the Java code that you use is not aware of this mechanism. And type return from Java code has no notion of nullability, okay? So Kotlin handles it very nicely, but in runtime, things can break. The other thing that may cause problem is the fact that whenever you use a map, when you try to get a value out of a map, if the key does not exist, you will get null. So this mechanism is like inherently creating nulls in your system. And when you try to access them, or even if you use the double bang operator, you will get a null pointer exception, which doesn't make a lot of sense because you might not understand what happened. So in order to tackle it, we added a method that's called require. If we have a map and we know that a certain key should be there, we want to return a string and not a string question mark, okay? So the implementation is looking into what we get to the key and checks if it is null. If it's null, it throws an exception, but with some context. It adds the key that we were looking for, and this results in a much better way to understand the problem when you get to it. So that was really nice, but then Kotlin 1.1 was introduced, and Kotlin 1.1 has a method called getValue, which does almost the same thing. It throws no such element exception where the key does not exist in the map, and if it does exist, it returns a non-nullable type, okay? So that in that way, you are keeping away the nulls from your code. Another thing that's worth mentioning within this context is called Delegate by map. Let's assume that you decided to put some key values in a map and you didn't model it like very strictly with a class. And later on you regret. There are some keys that are always in the map, you always need them, and what can you do? In Kotlin you can add a delegate property. A property that when accessed is actually using the map to see what's in there, okay? So even though we didn't define business name and the email address, we can access them as if they were properties of the class, okay? It just will take them from the mutable map or the map that we have there. So that is another way to eliminate nulls, because when you access business name, if it doesn't exist in the map, it will throw a meaningful exception. And business name is always non-null. So that's about nulls. JSON serialization, or I will say that this topic is also about API evolution. So I guess that by this point you understand that I'm a big fan of Game of Thrones. So you will probably need to know a bit of Game of Thrones in order to understand the following example. But let's say that we have two services, service A and service that is called Winterfell. And service Winterfell is exposing an API. And the API is set Lord of Winterfell. And we set the Lord of Winterfell to be Eddard Stark. We modeled an object that has a first name and a last name. And the right way to do it in Kotlin is to declare your data transfer objects as data classes. So what are data classes? Data classes are classes plus. Okay? So in Kotlin, every class also has getter and setter. No need to implement them. That's how it is done always. But if you use a data class, it's a bit similar, by the way, to Scala case classes, but a little bit less powerful. So you get implementation of hash code and equals that you don't need to implement. You get a copy method, which can help you copy the method in an immutable manner. And you have the structuring operator. Let's see how we are doing it. First, we define a class, a data class, Lord, with first name and last name. Okay? By the way, this line of code, to write it in Java, it's about like 50 to 100 lines of code. So that's why Kotlin is much more succinct in this manner. And then, if you want to create Eddard Start as Lord of Winterfell, you just use the constructor. And when you want to replace him with another Lord of Winterfell, you can just copy it and override the method, the properties that you want to change without damaging immutability. And if you want to use destructuring, you can just take the Stark in Winterfell and destructure it to first and last, or first name and last name. So everything is nice, and we have some kind of implementation and API. But then a few weeks later, episode 9 of season 1 arrives. And if you remember what happened, you will need another property now. Okay? So what can we do? We can create another API, or we can try to maintain the same API, but not breaking compatibility. So if we assume that every time the API evolves, we just add new properties to it and don't remove anything, at least not anything that is used, we can evolve the API in a very nice way. How this can be done in Kotlin? If you're using, for example, Java, you probably need Jackson, as we do. You probably need to start annotating a lot of things. You will need to annotate JSON property, and you will need to annotate ignores, and you need to annotate a lot of things. But what we're doing in Kotlin is just adding another property to the data class, and it is beheaded, and it is optional. And because it is optional, we're able to deserialize it when it's missing. So even the client did not upgrade to version 1.9, he will still be able to work with a server that is in the new version and vice versa. How this can be done? By adding some functionality to the object mapper of Jackson. You register a module that is called Kotlin module, which does some reflection, manipulation, and looking into the object. And you set two properties to fail on unknown properties to false, and fail on null for primitives to true. And when you are using it that way, the data class and the serialization works like out of the box, and you don't need to worry about annotating anything. Okay? It will just work. You added a new property, you make it nullable until all the clients are upgraded. When they are upgraded, if it is mandatory, change it from nullable to non-nullable, and you're done. If you remember the example from a few slides ago with the delegate by map, if you want to use it for serialization and deserialization, you will need to add JSON ignore on these properties. Otherwise, Jackson will try to serialize, deserialize them, and it will create a mess. Another feature that I want to cover is inlining and refide. What does it mean? You probably all know that the JVM is very strong in optimizations, and after warming up the JVM, it can inline methods. And by inlining methods, it's like eliminating them from the call site and just putting the code into the original method that called them. This improves performance and does a lot of nice things. And the JVM does this transparently. Kotlin has a mechanism to do inlining on compile time. I don't really like it because it means that when you look on a stack trace, the method that you inlined does not appear there. And it seems like it never existed, and you are not sure what was happening here. The reason that they added it is to reduce the number of functions, because when function and classes, because you're using Lambda expressions, classes are created in Kotlin, and methods are created, and especially if you're targeting your code to Android, it may cause problems because there is a method limit or something like that. I don't think it is an issue in backend development, but we do need inline if we want to use a mechanism called refide. And what is refide? Refide enables you to look much closer on the type that you pass to a generic function and do things that you cannot do in Java. If you remember, many times that you need to do something with types when you have generics, you probably need to pass the class as a parameter to the function. Otherwise, you cannot do some things. So refide enables you to get over this stuff. It is not very easy to understand it, but we do find one use case which is really useful. And what is this use case? Suppose that you have a table in the database that is some kind of an enum, like a reference table with ID and a string, okay? And now you want to reflect it in code. So you create an enum. And the enum has like textual IDs that are very rigid. And the problem is that when you get a result set, you need to transform from the string that you get or the ID that you get from the database to the strict enum. And in addition, it is very hard to understand whether the enum is sufficient or compatible with what you have in the database. So for example, if you added the renewal status in the database and forgot to put it in the enum, or you moved it from the database, you will probably have problems in runtime later on. So what we are doing, we are modeling the database table into the enum as well. We have the ID and we have the string as it is represented in the database. And we are inheriting from an interface that is called database enum. And what is database enum does? It has two methods that are inlined and refide that convert it from return an enum instance from an ID and from name, okay? And why do we need that? Because then we can take the ID, the number, and return the enum from it, okay? Quite easily. And the reason that we need to use refide is because we use the method enum values, which is a Kotlin standard library function that is refied itself. And refied methods, if we